less than 2. It is lesser than 2. So it is also valid. For the 3, for the last index, it is also valid. So we can see here, we can take height as 1 because it is, you can see, we can draw this 1 centimeter or 1 unit height in all these histograms. Okay, so this is 1, 2, 3, 4, 5. We will have 5 histograms of height 1 and breadth 1, 2, 3, 4, 5. So 5 into 5 is again 10. We have got our first answer. Now we will check for the next index, that is third index. In this index, we will check 5. Is it lesser than 6? Yes, it is. So we can consider these 2 histograms. Now we will go for fifth index. So is 5 lesser than 2? No, it is not. So it will break here. And we got 2 histograms of height 5 and breadth 2. So what's the output here? It is 10. That is 5 into 2. Length into breadth. Again, for 6, we will check there's nothing greater than 6. So we will skip to the next index. Now we have arrived at fifth index, that is 2, where its height is 2. Now we will check for 2. It is valid for 5, 6, and 3. Okay, so if we multiply 2 by 4, that is 8. This is our another answer. We will store all of our answers in a stack. That is, we have first stored our answer, that was 10. Second was again 10. Third is 8. And the last one, we got 1, 2, 3. 3 into 3, that is 9. So we will again push these answers into a stack, and we pop out when pop these out the answers, we got the highest one. We have just we just want to find the highest or the largest rectangle. So what's the largest rectangle we got? We got 10. That is 5 into 2. These 2 histograms create the largest rectangle. Okay. So this was the explanation. Now we will again understand there could be 2 approaches, brute and the optimized one. Okay, so what does this brute approach tells us? Let's say for these bars, considering the breadth of each one is 1 unit. For the first bar, area possible is 2 into 1. That is 1 square units. For the second bar, area would be 1 into 6. That is 6 square units. Then 5 into 2. That is 10. Again, we will do. So the maximum possible square units would be 10 for this height, for 2 height, and we will got. Now the another approach that we will use is the approach to find right smaller and left smaller element and find the largest rectangle area in the histogram that I have already told you. You have to check it whether the right most element is greater or lesser than the current element or not. Okay, if you check this and go throughout the last index, you will find the maximum output.
Can you
now
repeat what you said in the second procedure?
Okay, so the second procedure was, if you let's say you are at first index. Okay, I'm considering it as a first index. So you have to check first this index. At this index, the height, if it is greater than this or not. Let's say the height of the first index is 2. Okay, and the height of the second index is 1. So obviously it is lesser than 2. You have to break it. You don't have to just go throughout the last index. Okay, now you will jump to the next index, that is 1. Now you have to check if 5 is greater than this. Yes, it is. So you can move to this index as well, and you will count this index breadth is 1 and height is 1 again, and you insert or push these numbers into the stack. So then when you will move to this fourth index, you can see that 1 is lesser than 6. So you can again count it as 1 height and 1 width. Then you will go to this index, that is 1 again lesser than 2. For the same third again. So what you have seen that 1 is creating again a rectangle in this way. I can't draw here, but I guess you can imagine, like 1 from this block, 1 from this, 1 from this, and this. So what you have got 1, 2, 3, 4, 5. 5 into how many blocks are these? 1, 2, 3, 4, 5. 5 into 5, that is 10. Again, you got a rectangle in these histograms. Okay, so Rudra, is it clear? Yes, it is. Now we will move for the optimized one. Okay. So this is it. I'll explain you what we have to do. So the intuition behind this optimized approach is the same as finding the smaller element on both the sides, but in an optimized way, using the concept of the next greater element and the next smaller element. So what should be the approach? Steps to be done for finding the left smaller element is, since the height is at smaller than 0, since the height at 0 smaller, so we will remove 0 from the stack and add 1 into it. Okay, then we will again insert the lesser left smaller element. Then we will go for the another index, that is, since the height is at 2 is greater than the previous element, means the small element for 5 is 1. Okay, on comparing 2 with 6, it is greater remove, 2 with 5, it is greater remove, 2 with 1, this is right. So steps to be done for finding the height smaller element, it is done here, and you will create smaller and right smaller and left smaller stacks separately, and will calculate the areas using the formula, that is right smaller minus left smaller plus 1 into ARR of I, that is index. So the area for the first index would be 0 minus 0 plus 1 into 2, that is 2. So again, you will find these areas and you just have to return the maximum one, that is 10 in this case. Just give me 1 minute. So yes, I have been logged out from my LeetCode account. So here's the code. I'll explain you the code as well. First, we have declared this class, as you know, and the function. Here it is vector. Okay, for the previous smaller element. Previous smaller element takes a reference to a vector of integers that is input and returns a vector of integer. Okay, and we are obviously using stack, so you have to implement this declare stack of integers. Then we will push -1, initialize the stack with -1 to handle the boundary conditions. Okay, then we will again go for the vector. Int initializes a vector of answer of the same size as input to store the results. Now we will, for left to right, for the previous element, as I have told you, we will initialize a for loop which iterates over each element in the input vector. Now this current variable stores the current element. Again, the while loop checks and removes element from the stack that are greater than or equal to the current element. Now this answer I is equals to s dot top. That means this stores the top element of the stack. That means the previous smaller element in the answer. Now s dot push of I, that is pushes the current index onto the stack. Now this function is for the next smaller element. Next smaller is similar to the previous smaller element, but it finds the next smaller element for each element in the input vector. The main difference is two directions. That means for this for loop, it iterates from right to left. Now, this is another function. That means int largest area rectangle. So as you know, the function, as you can understand with the function name, you just have to find the largest area, and it takes a reference to a vector of integers height and returns an integer representing the largest rectangle area. Now this vector calls to get the previous smaller elements for the heights, and this is the loop to calculate maximum area. That means we will initialize to the minimum integer value, and this stores the height of the heights, and this for loop iterates over each elements in height. These are the stores the current height, and this adjusts the next value for the boundary condition. This is for the boundary condition, or you can understand it as a base condition. And this int width calculates the width of the rectangle. This area calculates the area of the rectangle, and this maximum area updates max area with the maximum area found. And at last, we will return the largest rectangle area. It is running. So next question is sliding window maximum. Again, we got hard one, but no problem. Now, sliding window maximum. What does this question means? You are given an array of integers now. There is a sliding window of size k, which is moving from very left of the array to the very right. You can see the k numbers in the each window. Each time the sliding window moves right by one position, return the maximum sliding window. So this is the array that is 1, 3, -1, -3, 5, 3, 6, 7. As you can see, we have given an integer k. That means k is the window size. So first you have to choose these three elements, okay? And then you have to find what's the maximum between these three, that is 3. So we have 3 as our output. Now we will go for another window size of 3, that is 3 -1 -3. In this, we have found that 3 is again the maximum. So we will again store it in some another vector or in stack to get our output. Okay, so we have got 2 3s as our output. Now the window size goes from this 1, 2, 3. Yes, -1, -3, and 5. As you can see, in this window, 5 is the maximum element. So again, you pushed out the 5. In the window -3, 5, 3, you have seen 5 is again the maximum. So we got our answer 5 as well. Once again. And in the window 5, 3, 6, we can see 6 is the maximum. So we got 6 here. And in the last window, that is 3, 6, 7, we got 7 as our largest. So we again pop out this 7. So we have got our answer, that is 3, 3, 5, 5, 6, 7. So what basically you have to do, you just have to see the integer given, that is k. Okay, this is the window size. You just have to traverse through this entire array in the size of 3. Okay, you just have to check 3 size in overall the array. Okay, so what would be the root approach? Let's say we want to look for a window of size k at a time and then shift to the next window. So why not to do exactly what we are asked to? We fix a window of size k at first and then calculate the maximum element in it. We then shift the window to the next position and do the same process until we exhaust all the possibilities. That is, we reach to the end of the array. Okay, as I have told you, you just first check this, then check this one until you have reached the last window, that is 3, 6, and 7. So we initially keep a left and the right pointer to fix our window of size k. Okay, let's say you have created a left pointer and a right pointer. So we compute the maximum element present in this window using the getMax function. Okay. Now, now further, you have to update the left and the right pointer by left plus plus or right plus plus. I'm telling you the brute approach. Okay. Now, every time you get to a new window of size k using a while loop, for every new window we encounter, we add the maximum element using the getMax function to our data structure. Okay. And what could be the time complexity if you are using this brute approach? It would be O of n square. Now, why can't we use this brute approach? Because there are number of windows and we have to traverse it. Like if this is the small part, but if you got an array with more elements, then what you have to do? You just traverse through it. No, you can't. So you will use step. Okay. Now, what could be the better approach? To understand this, we first need to check whether we are doing any repetitions or not. For this state, we get a maximum of 3. Okay, let's say I'll show you this root approach. Okay, so when you are using stack, you just have to do one thing. If you are at index 1, 2, 3, that means the k value that is 3, you have created a window size of 3 and you're traversing through 3 indexes. So you just find the maximum one that is 3 and add it into the stack that is 3. And you cross the index that is 0, 1, 2. Now 0 only. Then you will go for 3 minus 1 minus 3. What you have found? You found that 3 is again the maximum among these 3 indexes. So you push that 3 into the stack. Now, in the case of minus 1, minus 3, and 5, 5 is the maximum. Push the 5 into the stack. In minus 3, 5, 3, again 5. You push this 5 again in the stack. In 5, 3, 6, 6 is the maximum. You push 6 into the stack. And 3, 6, 7, you found 7 is the maximum and you put this 7 into the stack. So, and first index, you just have to cross out this first index, or you can just simply initialize it with minus 1. And once you reach the index, you can cross it out, okay, later on. So this is the optimized approach. And the time complexity here would be O of n. Interviewer will be very happy with you. And this is it. I have used DQ in this. It is better to use it. Okay, so yes. So first we have declares a DQ that is double-ended Q, DQ of integers. This will be used to store indices of elements in the sliding window. Now you have initialized a vector with declaring a vector answer to store the results. Okay. Store the results mean the results that we have stored into the DQ, that is 3, 3, 5, 5, 6, 7. These are the results. Okay. Now this loop iterates each over the nums vector. Now this condition, what this condition means, this checks if the DQ is not empty and if the front index is out of the current window, that is if it is I minus k. So if so, it removes the front element from the DQ. Okay. Now removing the simpler, the smallest element, this while loop, what does this while loop do? This removes all the elements from the back of the DQ that are smaller than the current element, that is nums of I. This ensures that the DQ always contains indices of elements in decreasing order of their values. Okay. Now, in this condition, this adds the current index I to the back of the DQ. Now, in this condition, this checks the if the current index I is greater than or equals to the k minus 1, that is the first window is complete. If so, it adds the value at the front of the DQ, which is the maximum value of the current window, to the answer vector. And at last, we will return our answer. As you can see, it is running. Now we will move to our next question. It is minimum stack. So let's understand this minimum stack. Design a stack that supports push, swap, top, and retrieving the minimum elements in the constant time. I guess you guys have done this question many times in your life. Just show the code first. So first, read this out. Minimum stack means initializes the stack object. Void push int value. These are the function here. Yes. Void pop removes the element on the top of the stack. Int top means gets the top element of the stack. Int get min retrieves the minimum element in the stack. You must implement a solution with O of 1 time complexity for each function. So stack would be the best option for this. Okay. Let's say you have given an input that is minimum stack, push, push, and so on. So what you have got? Minimum stack. That means the function is calling it null. Push, you have pushed this element -2. Again, you have pushed 0, you have pushed -3, you have found the get minimum. So in this case, -3 is the minimum among these three elements. You have pushed these three elements, that is -2, 0, and -3 into the stack, and you have just got this function. That means you have to just find the get minimum. And among these three elements, you find -3 is the minimum, and you have popped out. So here in this output, we got -3. Again, pop. What could be the first element at the top? That is -3. It is popped out. Now top. Who is on top? That is 0 is at top. Now you have to find the get minimum. Among 0 and -2, -2 is the minimum, and you have popped out this -2 out of the stack. Okay. So this is the explanation. Don't have to go. So what could be the first solution? Like the brute. It is very easy, but still I will explain you the brute as well. So the first element in the pair will store the value, and the second element, that means we will be using pair and value things. Okay. Let's say you have given a condition that is push -2. So what you have done, you have created a pair that is -2, -2, and then you have to push 0 again. The previous element is -2. You have pushed 0 again. Okay. You have found then the next function is get minimum. So no, the next is push -3. Then you again pushed -3 with it. And if you found get minimum, so among these three, -3 is the minimum. So -3 is the answer. Then you have to pop this out. -3 is at the top. So you will pop -3 and then get minimum. So among 0 and -2, -2 is the minimum. So this is an approach using pair and keys in pair. Okay. So in this approach, what you have to do, the first element is the pair will store the value, and the second element will store the minimum element till now. Okay. So among -2 and -2, we have pushed -2 here, first element, and among this first only one element, you have seen that -2 is the only element here. So definitely it would be the smallest element. So you again write -2 as the second element, that is the smaller one. Now in the next condition, when it is asked to push 0, so you will push 0 as the first element, and among 0 and -2, you can see -2 is the smaller element. So in the place of the second element, you just have to put the smallest element. So among 0 and -2 is the smallest element. You put -2 here. Now it is given that you have to push -3. So in the place of first element, you have pushed -3. And among -3, 0, and -2, you can see -3 is the smallest element. So you put -3 in the place of second element. Okay. And then you will find the answers, what the question is asked for. Okay. This is the approach. So in this, you have used pair, as I have told you. Stack pair, it declares a stack named st that stores a pair of integers. Okay, the first value and the second value, as I have told you. Each pair will store the value of the element and the minimum value at the time of the element's insertion. Okay. Now, this void function, that is push index, is a member function that takes an integer x and pushes it onto the stack. Now, for this minimum case, we will be determining the minimum value. Int minimum is what? Declaration of a variable minimum to store the minimum value. Now, this condition, if this means checks if the stack is empty. If it is, minimum is set to x. Now, the else condition, if the stack is not empty, minimum is set to the minimum of the current top's minimum value and x. Okay. Now, push pair onto stack. Okay. That is void pop. It is a member function that removes the top element from the stack. Okay. Int top is a member function that returns the value of the top element in the stack without removing it. It returns the first element of the pair at the top of the stack. Now this get minimum is a member function that returns the minimum value in the stack, and it returns the second element of the pair at the top of the stack. So what second means? The pair we are using. In the pair, dot first means it will give result of the first element, and dot second means it will give us the result of the second element. Okay. It is working fine. Now we will move to our next question. That is rotten oranges. Just give me 1 minute. Okay. So, rotten oranges. You are given an m into n grid where each cell can have one of three values. That means 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of the minutes that must elapse until no cells has a fresh orange. If this is impossible, return -1. Okay, so we will understand. We will try to understand what this question is asking. Okay. So first check this example. Let's say we have given this 211011101. Okay. So we have seen that 2 was representing a rotten orange. That means this orange is bad and it will give its impact in this direction, in this direction, in the left, upward, leftward, right side, or the downwards. Okay. So you just have to check in how many minutes we will rotten all the oranges. Okay. So there should not be any fresh oranges left in the bucket. And for doing so, you have to measure the time. You just have to measure the minute. Okay. In the 0th minute, it is the question given. So for the first minute, this orange will first rotten its orange in the right.
Processing frameworks like Spark, data orchestration tools like Airflow, and for
So in the first minute, this orange has rotten its rightmost element. Okay. So it also, the catch point is that it can only rotten the oranges which has the value 1. Okay. 1 means the fresh oranges. So first it goes here. Now for the second minute, what it can do, it will rotate the element that is in the back side of it, and it will rotate the elements that is in the right side of it. Okay, so as we can see in the minute 2, we can see there are 4 rotten oranges among all these. In the third minute, these both, this orange and this orange, these both can rotate this orange as well. That is, it is at the index of 0, 1, 2. Okay, so we can see at minute 3, 5 oranges are rotten. Now we have to check for these two fresh oranges, that is at the index 2, 2 and the index of 2, 0. In the minute 4, we can see this orange was able to rotate its orange in the downwards, but this is again safe. So in this case, we will return our output as -1. Why? Because one orange is still left. It is not rotten. It is fresh. So the question was, if it was again, so what the all of oranges, all of the fresh oranges we have turned into the rotten ones. But in this case, we but in this case, uh just give me 1 minute. Okay, so I guess the approach is clear. Now we will go for the intuition or how we will solve this question. There are many ways for solving this question. So the first and the best approach would be using BFS. Okay, that would be the easiest one. So, as you know, how we will apply the BFS in this question. Let's say the grid is 0, 1, 2, 0, 1, 1, 2, 1, 1. Indexes are 0, 1, 2, 0, 1, 2 again. So in the queue, for the BFS, we need queue. In this queue, what we will add the indexes. For this orange, what would be the index that is 0, 0, but we don't have to see this index. We just have to focus on the index that is this 0, 1. Okay. And another one is at 2, 0. So what you have to do, you will just traverse it. Let's say you have filled out the indexes as 2, 0. That means 2, 0. This is the first element. And is it able to rotate any of the oranges? Yes, it is at the index of 2, 1. Okay, so we will cross it out. Now this will again be able to rotate these two elements, that is at index 1, 2, 1, 1, and at index 2, 2. Now all these oranges are rotating. For this element, it is also rotating. So it will get 1, 2. And this is the last fresh orange. This will again rotate this orange. So in this case, we have written all the oranges and we got our answer at, we will count the minutes in how many minutes we were able to rotate all the oranges. That would be our answer. Okay, that would be a minimum time required. We'll understand the code. So first is you in this function of oranges rotating, if the grid is empty, it returns 0 since there are no oranges to process. You have seen if the grid is empty, there's no need to, you don't need to go or you don't have to traverse through it. So the answer would simply be 0. Now, you have initialized m as it stores the number of rows and n as it stores the number of columns of the grid. Now, what are the days? Days initializes a counter for the number of days, okay, or the number of time. And TOT means initializes a counter for the total number of oranges. Now, CNT is the initializes the counter for the number of rotten oranges processed. Now in this queue, we have used queue. Why? Because we are using BFS algorithm, and for that we have to use queue in it. Okay. So in this queue, we are initializing a queue to store the positions of rotten oranges. Make sure we are using queues just to store the position of rotten oranges. Okay. And in this nested loop, iterates each cell in the grid. This means if it increments total TOT for each cell, this is not empty. That is, it contains an orange. And for this condition, you can see it adds the position of each rotten orange to the queue. Okay. Now you will ask for what is the day X and dy. These are the arrays that define the 4 possible directions of movement. That is left, right, down, top. Okay. Let's say if this is the orange, it can go in its left, right, top, and down. Okay. Now this loop continues as long as there are rotten oranges in the queue. Now for this variable int k, that means it stores the number of rotten oranges at the current level or the day. Now the CNT means it increments the count of the processed or rotten oranges by k. Now for this while loop, this inner loop processes each rotten orange at current level. Let's say this is index, means what does it mean? It gets the position of the current rotten orange. Okay, what would be the position of the current rotten orange? We got it from here. And rotten.pop means removes the current rotten orange from the queue. Okay, now this is the nested for loop with for iterates over the 4 possible directions. And these nx is equals to x plus dx. It calculates the new position. Nx is definitely for the new position. Yes. Now, this if condition checks if the new position is within the bounds and if contains a fresh orange. If not, it continues to the next direction. Okay. Now this grid marks the fresh orange at the new position as rotten. For this rotten.push, adds the new rotten oranges to the queue. And in this case, if this is the increment days, basically, if there are still rotten oranges in the queue, it will increment the day counter. Okay, if anything is left or the rotten oranges are left, it will increment it, and we will at last return the number of days if all the oranges have been processed. Okay, otherwise it will return -1, indicating that no all oranges can rot. So this question is also done. Our next, that is online stock Spain. So first we will understand what does it mean. The span of the stock's price today is defined as the maximum number of consecutive days starting from today and going backwards for which the price of the stocks was less than or equal to today's price. Find the span of the stocks for all the days. Let's understand this graph. Let's say this is an array 100, 80, 60, 70, 60, 75, 85. This question is very easy actually. So first, this is 100. Before 100, are you able to see anything lesser than 100 or equals to 100? No, there's nothing lesser than 100 but equals to 100. That is 100 itself. So the answer would be 1. We will store 1 as its answer. Now for 80, are you able to see any number lesser than 80 in its backward direction or in its previous indexes? No, we can't see. But 80 equals to 80, that is 80 itself. So we will again return 1 as our answer. For the 60, you have to check, is there any number lesser than 60 in any of the previous indexes? No, we can't see anything like that. And 60 itself is equals to 60. So we will return 1 again here. Now for say 70, you have to check. For this 70, I can see that 60 is lesser than 70 and 70 is equals to 70. So what would be our answer? That is answer plus 1. So we have returned 2. That is 60 and 70. Okay, so we have returned 2. Now for this 60, you have to check if anything lesser than or equals to 60. You can see there is 160 that is equals to 60. So you will return 1 only, and there is no number that is lesser than 60. Now we will move to 75. Okay, for the 75, you have to check any number lesser than 75 or equals to 75. So first 75 itself, 1, 2, 3, 4. So you have seen there are 4 numbers that are lesser than or equals to 75, and we have returned our answer as 4. Now for this 85, you have to check. For this 85, first is 85 itself, then 75, that is 2, 1, 2, 3, 4, 5, 6. You have seen that 6 elements are lesser than or equals to 85. So we have returned our answer as 6. I guess it is clear. This is it. Okay. And its code is also very basic. So first you have again seen, we have also taken pair, stack pair, that is ST. And this is the main function, that is the int function, which contains int prices. Okay. In this, int span means it initializes the span for the current price. And this while loop checks and pops the elements from the stack as long as the current price is greater than or equal to the price at the stack stop. Okay. Adding their spans to the current span. After calculating the span, push the current price and its span onto the stack and return the calculated span. Was very straightforward question. Okay. Now we will move to the next question, that is maximum of minimum for every window size. You may sound this question as clingy or you will find it like difficult or confusing, but it is not. You just have to first focus on the last these words. That means minimum for every window size. Let's say this window size is 7. Okay. No, I will explain you this. Okay. In this question, you can see there is an array. Okay. 10, 20, 30, 50, 10, 70, 30. Okay. and the window size is 7. So you will create 7 windows. That is 1, 2, 3, 4, 5, 6, 7. And for each window, what you have to check, I'll explain you. So in the first case, what you have to check, that is 10 is itself an element. 10, 20, 30, 50, 10, 70, 30. Among all these elements, what you can see, what's the maximum element out of these elements? That is 70. Okay. In the window size of 7, that is 1, 2, 3, 4, 5, 6, 7. Next window size would be of 20, 30, 50, 10, 70, 30. We will decrease it. Okay. So next what would be 10, 20, 30, again 10, 10, 30. Among these window sizes, what you have found? 30 is the maximum. Okay. Now for the next window size, that is 10, 20, 10, 10, again 10. And among these 5, you have found 20 is the maximum. You will find out the 21. Okay. And then what left? 10, 10, 10, 4 times. So you will return simply 10 4 times. And you can also see that it is in the decreasing order. Okay. 70, 30, 20, 10, 10. So what you have to found out in this question, you just have to find the first, you have to find the minimum in the window size, and out of all those minimum elements, you have to find the maximum one. Okay. So you can understand from here as well. The first element in the output indicates the maximum of minimums of all window size of 1. So for the first window size, that is itself 1. In this first window size, it is again 1. So these are the elements of window size of 1. And among these elements of window size 1, which is the greatest or which is the maximum element or the greatest one? You can see 70 is the greatest element. In the window size of 1, you have returned 70. Now, in the window size of 2, that is 10, 20, 20, 30, and 30, 50, 50, 10, and 10, 70. So, first understand this. 10, 20, minimum element is 10. 20, 30, minimum element is 20. 30, 50, minimum element is 30. 50, 10, 10 is the minimum. 10, 70, 10. 70, 30, 30. And all the remaining elements, this 10, 20, 30, 10, 10, 30, among all those, what you have? Find maximum element is 30. You have returned this 30 here. Now you will create a window size of 3. That is 10, 20, 30, 20, 30, 10, and then 30, 10, 10, and then 10, 10, 30. And among these, you have to find the minimum. So for the first window size of 3, that is 10, 20, 30, you can find that 10 is the minimum element. So you have written 10 here. In the window size of 20, 30, 10, you can see 10 is the minimum. You have again put this 10. In the window size of 30, 10, 10, again 10. 10, 30, 10, 10, 10, 30, again 10. And the maximum among these is the 20. So you will return 20 here. And for the same elements, that is 10, 10, 10 is equals to the same. So you don't have to iterate for all the 4 remaining elements. You can simply return if the element is equals to the current element. Okay. So this is the code. I'll explain you. In this vector function, so it takes an array. Okay. So this vector function, this function takes an array of length n. Then see length n, and returns a vector of integers. The goal of the function is to find the maximum of the minimum values for every window size in the array. Okay. Now we will come to the variable declarations. So in the first, we have declared a stack to use to keep the track of indices. Left and right pointers to store the indices of the nearest smaller elements on the left and the right of each element in the array respectively. Okay. And this answer vector is a vector of size n plus 1 that will store the maximum of minimum values or all the window sizes from 1 to n. Now we will initialize left and right array. So initialize left array with -1 indicating no smaller element on the left side, and right array with n indicating no smaller element on the right side. Now we will fill left array. How we will fill this left array? We'll understand it. We will first iterate through the array to fill the left array. Okay. This is it. filling the left array. For each element, what we are doing, we will pop elements from the stack while the top of the stack is greater than or equals to the current element. Okay. This ensures that the stack only contains the indices of the smaller element. If the stack is not empty after the popping out the elements, the top of the stack is the index of the nearest smaller element on the left. Okay. Then you will push the current index onto the stack. This is it. Now this while loop is for the clearance, for clearing the stack. Okay. Now, this for loop is for filling the right array. Filling the right array. What does it mean? We will iterate through the array in the reverse order, okay, to fill the right array. For each element, you have to pop elements from the stack while the top of the stack is greater than or equals to the current element. This ensures that the stack only contains the indices of smaller elements. If the stack is not empty after the popping, the top of the stack is the index of the nearest smaller element on the right. And at last, you have to push the current index onto the stack. Now you will initialize again. And for this for loop, fill the answer vector with the maximum and minimums. Here you are filling the answer vector with the this is this array you have initialized for storing elements, and for this for loop is vector with maximum of minimum. Yes. For each element in the array, you just have to calculate the length of the window where the element is the minimum, and then update the answer vector to store the maximum of minimum values for each window's length. Okay. In this, you just have to fill the remaining answer element. Fill the remaining answer element. Okay. Ensure that the answer vector correctly reflects the maximum of the minimum values for all window sizes by propagating the maximum values backward. Okay. And then you will finalize answer vector. And remove the first element of the answer vector. Since it's unused, we are interested in the window sizes from 1 to 0, or 1 to n, not 0. And we will simply return the final answer vector. Okay, so it is also running. Now we will move to our last question. That is the celebrity question. It is very easy. So in this question, a celebrity is a person who is known to all but does not know anyone at a party. Okay. You also know celebrities are like everybody know them, but they don't know us, or they know only few of the people. Okay. So in this case also, a celebrity is a person who is known to all. Who is known to all means everybody knows him or her, but does not know anyone at a party. In the party that he is attending or she is attending. So she doesn't know anyone there. If you go to a party of n people, find if there is a celebrity in the party or not. Okay. And if you are going into a party, so you have to find who is the celebrity there. Okay. So how you will find this? We will understand it later. A square n into n matrix and m array is used to represent people at a party, such that if an element of row I and column j is set to 1, it means ith person knows jth person, where m of I will always be 0. And simply you have to return the index of the celebrity. If there is no celebrity, then return -1. What's the note? Follow zero-based indexing. Okay. Follow up, you can optimize it to O of n. Okay, we will solve it in O of n. So we'll understand this. Yes, this is the celebrity problem. What are the two basic conditions? First condition was everyone knows the celebrity. Okay, we know that. Second condition is celebrity known no one. Celebrity known to no one. Okay. So what you have to do? You will create a 2D vector like this. It is also given here 0, 1, 0, 0, 0, 0, 0, 1, 0. Okay. In the same way, let's say we have given 0, 1, 0, 0, 0, 0, and 0, 1, 0. You have to ignore the diagonals, or otherwise you will count diagonals as well. So first ignore the diagonals. Now the condition says known celebrity knows nobody and everyone knows him. So first we will check these index wise 0, 0. Do they know each other? No, they don't know. In the case where this 1 is there, let's say in the index of 0, 1, 1 is the answer here. So you have to check for these two 1. You don't have to check for 0. 0 means they don't know each other. And 1 means there is some relation. So for that relation, you just have to check where is 1. 1 is placed at the index of 0, 1. And the another one is placed at 2, 1. Okay. So you have to find who's the celebrity among this. First, we will go for 0, 1. Does this 0th person, knows this 1? Yes, this no. Does this 1 know 0? No, it doesn't know 0. Does this 1 know this 1? No, it doesn't know. This 1 knows this 2? No, it doesn't. 0 indicates that they don't know each other, and 1 indicates either of them knows them. Okay. Now, 2 means 2, 0. In this case, 0. That means 2 doesn't know 0th person. Okay. And in this case, does 2 knows 1? Yes, 2 knows 1. That means here it is 1. Now we will move to the another index, that is 2, 2. Here it is 0. That means 2 doesn't know 0. So 2 probably is not a celebrity, we know. Why? Because we can see 2 doesn't know 2. That means this one person doesn't know this another person. That means, and in the case we have seen for the celebrity, everybody know him or her. So 2 is obviously not the celebrity. Now for the 0, does 0 knows 0? No. 1 knows 0? No. 2 knows 0? No. Nobody knows 0. So 0 is also not a celebrity. So we have popped out these two people, that are 0 and 1. Now we will check for 1. Can 1 be a celebrity? Now let's check this out. Does 0 knows 1? Yes, it does not know. And does 1 knows 1? No, it doesn't. Okay. Why? Because 1 is itself the same person. Now you have to check. Does 2 knows 1? Yes, it knows. So from this condition, from this approach, we have found out that 1 is the celebrity. Why? 0 also knows him and 2 also knows him. So 1, we have declared that 1 is the celebrity. So this is the code explaining this as well. Okay. So in the private function, we have this whole operation that means knows, and we have initialized a vector m. A and B and n are the variables, and you have to check if m of A and B, that means we have 2D vector. Okay. If it equals to 1, that means you have to return true, and if it is not, that is false. That is the grids we have created. Okay. These are the grids that we have created. This is here as well. Now in the public test case, this is the celebrity function, and this is the stack, and this is the for loop. You will push the items, you will push the elements into the stack. You will check the size. If it is not greater than or greater than 1, you will do these functions, and you will initialize the 0 count. That means you also have to increase the count now. And for this for loop, you will count. If there is number of zeros, you will count 0 count plus plus, and if it is not, then you will return -1. And for this, for saying 1 count, you will also do the same thing, and simply at last you will return the answer. It is also done. So we are done with questions. If you have any doubt, you can ask me, and thank you.